Hi folks, welcome again to another tutorial. Let's look at another real-world problem and try to come up with a solution for it. Now, this is going to be a digital safe system. We all have these safe systems at our homes. You must have seen something like this at banks also. So the idea is pretty simple. We are going to design a digital safe system which can take the input, which will be basically a code, and using that code we can lock or we can unlock the system. So we are going to design a simple digital safe using combinational circuit. Assume that system has a 4-bit predefined password. We will use 4 switches as the input to the system. If the input matches the predefined password, then the first output will have logic level 1. Otherwise, the second output will have logic level 1. Okay? Alright, we can implement the corresponding combinational circuit using an exclusive OR gate followed by a NOT gate for each bit to be tested. So we can get this done simply by using a combinational circuit in which we will going to imply exclusive OR gate. Let's look at the truth table for the exclusive OR gate. With inputs A and B, the output is 0 when the inputs are same. So if you look at it, A and B being 0, output is 0. A and B being 1, output is 0. So similarly over here, these S0, S1, S2, S3, these could be switches that we are going to use on Basys 3 board to put in the password. And this is P0, P1, P2, P3 is the predefined password. Anytime this switch input matches with this bit on the password, it's going to generate 0 at the output of the exclusive OR gate, which then goes into inverter, becomes 1. And if this is true for all of these, whenever it matches, it's going to be 0, which then all these inputs going through inverter gives you 1. And we know the logic for the AND gate. Anytime we have all the inputs set to 1, it's going to generate 1. At the output, we're going to use 2 LEDs. One would display as a lock, the other one would display as an unlock. And also we are going to run these 2 wires into the 7 segment, and that segment display is basically going to display when it's locked, it's going to display L. When you unlock it, it's going to display unlock. Okay, which means your input switches basically matches the predefined password. So let's get rolling, and hopefully after we get this done, you can add more features to it and make it a little more advanced. So this is a very basic digital safe system. Let's get started. So just to expedite the process, I went ahead and created a new project, and I created a new source file which I named it as digital safe, and I'm going to work on it defining my ports and then finish the code for this digital safe. I'm also going to make a little change to the block diagram that I just showed you. This having 4 input switches, which will be S0, S1, S2 and S3. Instead, I'm just gonna go with a 5-digit code for this safe system. So input, these will be switches. Let's declare them as array, and I'm just going to use variable in. So this is going to be the switches which is going to be used to enter the 5-bit code. Then we need 2 LEDs. One would display that it is being locked, the other would display if it's being unlocked. So those would be output, and I can just use the status, and because I need 2 of those, so let's declare them as array as well. So my inputs and output, this is done. Let's also define the come up with a predefined password. So I can use the command parameter and say the code is, what do you want to set to? Say 0 1 1 0 0. That makes a 5-bit. Moving on to the next part of the code, which is going to be assigning the equation for the two status that we can have. One is locked, the other one is unlocked. So this is being I0, this is being unlocked, and this is being locked, I1. So here, assign status 1 with an equation for it. So the equation will be, these are all exclusive OR, and then basically exclusive NOR, because you have a NOR not in front of the exclusive OR. So in 0 hat you have code 0, and I'll just put it in brackets. This is an exclusive OR, and because we have a not here in front of the exclusive OR, so in brackets and then use this inward sign, and then all of these are being ended together with this AND gate. So and I'm just copy paste this thing so I can I'm just gonna make sure I have these AND operators between each of these brackets, and then over here. So I should have 5, 1, 2, 3, 4, 5. The other thing I need to change here, and this is gonna be 1 now. This becomes 2. This becomes 3 because we're gonna have 5 switches. 3, and then this is 4. So that's pretty simple. I basically used this combinational logic diagram and came up with an expression. The only change I did, which I mentioned earlier, instead of having 4 switches, I'm decided I'm gonna have 5 switches as an input. So it's gonna be a 5-bit code. So status is going to be the unlock. Of looks like my code is ready. I'm going to save it and then synthesize it. It's running the synthesis right now, and it should be done in a few seconds. This is complete. I'm not going to worry about the implementation right now because I need to make another source file for the 7th segment. So let's get going. And here's the source file for the 7th segment I just created. The first thing we need to do, we need to define our ports, the inputs and the outputs. Here, remember the status of the code, which is either it could be locked or it could be unlocked, will go into the 7th segment. So input, and I'm just going to declare them as an array, and there are 2 status only. So I can just say then I would need output 7 segments, so let's declare them as array as well, and then I'm gonna start the code saying always at that is when, and followed by begin, and yes, let's use the case word here. If 2 bits are 0, 1, which would mean status 1 is what? Status 1 is for the lock. Okay, so I would want to present L at the segment. Segment would be equals to, and then so if you look at the segment right here, in order to represent 7A, B, not 7, L, So L would mean F, E, and D needs to be on, and A, B, G, C needs to be 0. F is going to be 1, E is going to be 0, G is 1, F and E and D are going to be 0. This is going to represent L. If it is 1, 0, and status 1 is high, and status 0 is low. Status 0 let me go back to my data save. Status 0 right here. Yes. Unlock. U on this. Okay, so say seg goes to 7. Here. E. So for U, the 7 segment, everything will be on except for A and G. A and G. Okay. F, E, D, C, B. Okay, and okay. So remember the way these LEDs segments are. The first one is G, and then F, and then E, D, C, B, and A. This is G, and this is your A. Good. Display U. In case here and here. Let's go ahead and save the file and run synthesis. It's running synthesis now. Should be done in a few seconds. And it returned me with an error, so let's see what's up. Non-register segment. I need, because I'll be storing the value for these segments, so I need to register, declare register. I'm gonna click OK here, and then run synthesis again. So hopefully this works out, and we should be able to successfully synthesize the 7-segment module that we created. After we get done with this one, the last step would be to putting everything together in a top module where we will be displaying our output on both LED and the 7-segment display. And then also we will need a constant file. Just wait for another few seconds. Perfect. Went through successfully. I'm just gonna close this dialog box, and I'm gonna create a new source file for our top module and get the code ready for it. We'll start working with our port identification input. Remember, it's a 5-bit code, so we would need 5 switches to declare the code. So let's declare them as an array. And I'm just gonna use the variable SW because that's how the Basys 3 constant file by default uses the name for the switches SW. So we don't have to make that change in the constant file. So that saves a little bit of time. The output here is going to be 2 of those. I'm just gonna say, okay. We need our 7 segments here. So I'll just say seg, and then put enable. We need enablers, so I'm only going to be using one of them only. I can just These are going to be the two LEDs that would display, that would basically tell us whether it is logged or unlogged at a point. 7 segments, and our enable for 7 segment here. We are actually going to use only one of those, so let's use an assign function. Assign n equals to, we have 4 of those. Because it's being active low, so I'm just meaning 0 is on, so I'm only going to use the rightmost LED. Basys 3 board. Now I need to instantiate the 2 modules that I created earlier. Segment and digital 6. So I have to make sure that the name matches exactly the way I have named the files. So 7 and use 0, that's the identifier name. And we have input segment outputs and digital save 1. Those are going to be the switches. So view as inputs and the output is going to, I believe my code is pretty much ready. I just need to compile it now. So, and oh, it returned a critical error. Let's see what. Okay. I am actually missing a variable in here. So because this was the enable, so the end here. Let's go ahead and save it again. Everything looks okay. As you save the file, you should also see the hierarchy. This is your top module, and under that module you see those 2 sub-modules which we have instantiated here. Let's click on this file and click on implementation and click well, before we do that, the constant file, I already went ahead and put constant file up here. I was earlier working on a different project, so that's why it's named home alarm system. Know that, please. We need 5 switches, so those are the 5 switches right here. SW0 1 2 3 4. Again, make sure this is basic, but someone who is just watching the video and new to Basys report, make sure that your top module, when you're defining your inputs, the variable name matches exactly the way it should be in your constant file. Okay, all right. Then we need 2 LEDs, one for the log, one for the unlog. Again, we are using status variable here. So we have status. Notice one thing, because I have status here with s being in lowercase, and then in constant file I'm saying s in uppercase. So either I fix it over here or over there. I'll just fix it over here. This needs to be in lowercase. Similarly over here, s needs to be in lowercase. I got my 7 segments after that, and the 4 enables, and an, the variable name for the enable, and sec for the 7 segments. So everything looks okay. I'm just going to click my top module, save it back again, and then run the implementation, and it should take a minute to process it, and after that we should be able to generate the bitstream file. It roughly took about 2.5 minutes to get the implementation complete, and now it is done. We can move on to the generating a bitstream. So click over here, and then it should you should be able to see the status on the top right corner of the screen where it says running right bitstream. And again, it might take like a few seconds, so just be patient. Alright, sweet. Bitstream file has been generated, and as soon as you get done with it, this dialog box will appear on your screen. Click on your Open Hardware Manager, then click OK. Connect your board, make sure the power is on. Click Open Target, next, next, and here it is. Select your board, click Next, click Finish. Oops. For some reason Vivado just crashed on me, so I had it saved, so I'll just open it from here. The bit file was already created, so I don't have to redo everything. I can just go here, click Open Target, yeah, and then do this process again real quick. Go, click Next, Finish, Program Device. It should automatically pull the most updated bit file. Click Program, and you should be able to see the implementation of your digital safe system on Basys 3 board. Alright folks, so this is our digital safe system that we just created. The design has been implemented on the Basys 3 board. On the bottom you see switches, and we are using the first 5 switches from the right. The LED 0 is right now light on and it's displaying the safe is currently locked. And you see display L being displayed on the 7th segment as well, meaning the safe is locked at this point. If you remember, the predefined password that we chose for the safe system was 0110. So let's try that combination and see if the LED goes off and the sign changes from L to U. So 0110 would mean that this is supposed to be 1 and this goes to 0. 0. There you go. So I'm making a code of 0, 1. Sorry about that folks, that was my daughter. I got a 2-year-old daughter and she was whining about, she was watching Baba Black Sheep and the battery on the iPad died on her, so she was upset about it. And notice if I mess up with the sequence for the code, say I turn this to on position, it goes back to locked again. And in order for me to unlock it, I have to make sure that I am putting in the right password. So 0110, the LED then on the leftmost, that tells you it's unlocked, and you see the U being displayed on the 7th segment. Well, that's pretty much it from this tutorial folks. I hope you enjoy. You can add more feature like I mentioned earlier at the beginning of the video, make it a little more advanced, and even share your stuff with me also. Okay, please give me your feedback. I get a lot of motivation by reading your comments and getting your feedback. Please subscribe to the channel and keep watching. Thank you. Bye.